Hello, this is the ninth part. This is sorting a 1D array into a 1D array of integers into ascending order or descending. Now you might see that I have already written out everything. This is a different notebook after all, as we're going to be going over 3 different ways to approach this problem. And I don't know if it's going to be on the quick test, but it might as well be that he does ask for a specified way of doing it, but I don't know. I don't think that's probable. However, it might happen. So it's best to go over every single way, every single way that we did, rather. The first one that we did was bubble sort. And let me just move this over here, as this is a bigger version, and it's the better version, because what was there before had a bit of an issue that I will mention when we go here. Now, of course, we start by inputting our array, like always, and we have a more classic version. Now, what you saw here is that when we were checking for ascending order, we use the same first condition, because again, we do not want to swap or check things that are outside of the array. Of course, when the condition is not met, you output A and you stop. Now, if it is, we put in 2 values. One is going to be our checker. Not going to be using I, as with sorting, you might take one number and move it multiple times, so we want to have another loop. We don't want to use this one. Here we use k is smaller than n minus 1 minus I. Now, why do we do minus I? We do this because once we're done with one of the digits, we're done sorting it, we just don't need to touch it. So after it's met, this condition, we check if ak is bigger than ak plus 1. Now, if it is, so if the first digit, so if we have an exemplary array, we check if the first number in the array is bigger than the second one, because if it is bigger, we would like to swap it, right? So if it is, we do the classic swap. Like you can remember some of these chains of orders of doing things. So we do the swap, we increment k, and then we go back, and we do this all the time. And after it's turns out no, here's where our different variable comes into play. Because normally we would do I plus plus. We would just increment I and go on with the outer loop. Now, why do we have a condition here? This condition is for if we manage to sort the entire array before, or rather in fewer cycles than n minus 1. So, and we do this by having another variable every time we enter the inner loop. So at the same time as k, we have this set to 0, because this C stands for counter. And what we are counting is if we are making swaps. And as you could see, here I made that if yes, it goes over the swapping and adds in 1 to C. This is so we know that we swapped a digit. So when this condition is false, we can check if we did any swaps. Now if we didn't, we stop, because even if I is, for example, 4 and n minus 1 is 5, then if we went through, when we had I equals 4, and we went through this entire array without swapping, so we already swapped the entire, like managed to organize the array in 3 cycles, we just exit quicker, like a quick exit, so we don't have to do those remaining operations. That was bubble sort, so that was the easier one. Now I'm going to move on to selection sort. And sorry, let me just explain quickly. Bubble sort is just checking the first number and then checking the first number and moving it from left to right and left to right now. So you take so you have an example here. We have 1, 2, 3, 4. Sorry, I can't have this order. We have 5, 1, 2, 3, 4, and so we'll be swapping this with this, that with that, that with that, and that with that. Meaning our end is so we're taking numbers from the left. Oh, sorry. We're taking numbers from the left to the right and to their position, and we find this position by seeing if this first digit is bigger. So for example, if here we had 7, actually, this order would be a bit different. Here we would have 1, 2, 5, 7, 4. This would be after the first cycle, of course. And after every cycle we go through, it will sort itself into place. Now we go on to selection sort. This one has a bit of a different approach. As here we will be finding the biggest number, and then we will be yeah, I think that's right, my bad for the pause. So of course we do something very similar here, kind of, except for this. Here we're going to be n minus 1, and then we're going to be removing 1, because we're going to be moving from right to left. Now, of course, if we're going to be taking such an approach, we're going to be checking if L is bigger than 0. Because if it is not, that means we are going to finish and that we have done the operation enough times. This can of course be kind of changed into, to how we did in the previous ones. Here we start with I as 0 and k as 1, because we're going to make it easy, kind of, by having 2 separate, instead of doing like I is bigger or smaller or whatever than AI plus 1 or minus 1. I guess you could do that, but this is more beginner friendly compared to what I had written for bubble sort. Now we check if k is bigger or equal than L, as k is in our starting position is our second digit, like second index position in our array. So it is the last one. So we want it to be smaller or equal, because if it would be smaller, then we're doing one too few swaps. Now we do if it is, then we check if AK is bigger than AI. So if, for example, let's make a smaller right here, 5, 7, 4, 2. We check if AK. If it is, we do a I is equal to K. We do I is equal to K. My bad. So we turn I into K, and then we increase K to 2. So we have I is equal to 1 now, and K is equal to 2. And then we, after the next time we go through it, we will see that it is not smaller than AK is not smaller than AI. Sorry, not bigger. It's not bigger. So we go into no, and we increase K to 3, and then again to 4. We go 3, and then again to 4, at which point it is equal to L, meaning that we have no in this condition, and then we swap AL, so we swap this number, the last one, with our biggest number, because this loop over here checks for the biggest number in the array. And then after we find it, we keep its index, and then we put it at the last position. After this, we do L minus minus, because we already know that in this position, in this box over here, my bad, if this is 2 and this is 7, we already know that here we have the biggest number. So we don't need to check this box, we just check all the rest. As always, if you have any questions, comment.